It's Chinelanu here, and in today's video, we are going to be looking at a very important maths concept known as indices or exponents. Some people love to call it indices, while some others call it exponents. Whatever you decide to call it, that's fine because the concept remains the same, though the term may differ. Having said that, what then is indices? Just like the four mathematical operations we have, indices is a type of mathematical operation that tells us what to do with a number. So, what does it tell us to do with a number? It tells us the number of times a certain number is to be multiplied by itself repeatedly. So we can also say indices is a way of repeating multiplication or repeated multiplication. Now we've understood what indices is. Let's take a look at the structure of indices and its components. Why do they appear the way they are? And what are they made up of? Now looking at these, we understand that indices is made up of two numbers. In this case, a bigger number, 6, and this is the number that is repeatedly multiplied by itself. It is referred to as the base. Then there is a second number at the top right, just beside the base, known as index or exponent. This determines the number of times the base is to be multiplied. For example, if we have this, that means 6 is to be multiplied 3 times. 6 times 6 times 6. Again, when you multiply 6 3 times, the result you get is referred to as the power. I'm referring to the number after the equality sign, that's at the right hand side. So now we understand its structure and its component. How do we go about naming indices? In naming indices or exponents, a very important or interesting terminology is being used. For example, we can read this as 6 to the power of 2, 5 to the power of 7, 3 to the power of 8, and so on. A very important thing we also need to note about indices is this. Indices does not have a commutative property. What do I mean by that? When the orders are interchanged, you cannot get the same result. For example, if you have 3 to the power of 4, you're going to have 3 times 3 times 3 times 3, which gives us 81, right? Then when you switch it, 4 to the power of 3, you're going to have 4 times 4 times 4, which gives us 64. You can see the answers are not the same. Therefore, indices does not have a commutative property. Now, think of it. You hear of index, indices. What's the difference? Kind of sound alike, right? Index is simply the singular form of indices and a combination of the base and the index gives you indices. So now that we know that, let's take a look at how this can be applied in mathematics. So when you have 3 to the power of 2, it simply means 3 times 3. And when you have 3 to the power of 3, you have 3 times 3 times 3. And when you have 3 to the power of 4, you have 3 times 3 times 3 times 3. It's absolutely easy, guys. So now that we have understood that, how about the symbols of indices? Initially, indices was defined as a type of mathematical symbol. So does it have symbols like addition and multiplication? Well, yes and no. At times it does, and at times it doesn't. Its application could be necessary in some points. For example, if you're to write indices on a piece of paper in your book, already you know it has a big and small number, so it does not need a symbol. All you simply do is to write it. you cannot make the mistake of saying 2 to the power of 5 is the same as 25. However, if you're going to be imputing indices in a laptop or a computer, then you will need a unique symbol known as character. So you're going to be imputing it this way. 3 to the power of 4 will be 3 character 4, and 5 to the power of 6 is going to be 5 character 6. 8 to the power of 4 is going to be 8 character 4. That's simple. So how about when you have exponents that occur in 2 digits? Because in the previous examples, we've been looking at exponents that are in 1 digit, such as 8 to the power of 4, 6 to the power of 7. But what about when you have exponents like 6 to the power of 14, 6 to the power of 84? How do you go about handling this? You can make use of a scientific calculator. So if you have a calculator, here's what you do. Simply press this, and when you have done that, go to the replay button and you press the arrow by the right. And once you do that, you're going to be imputing the index right there, and that gives you your answer. Wow, look at how we've solved something that ought to take us a long time in a very short time. Wonderful, right? Again, an index can occur in fractional form, decimal form, or even be negative numbers. It must not always occur in positive numbers. We are going to be looking at that in details in subsequent videos. So now we've understood the structure of indices, its components, and what it is. I would love to end this video by looking at the two most common type of index or exponent, which are 2 and 3. Very often, we see numbers being expressed as raised to the power of 2 or raised to the power of 3. For example, if you have 5 raised to the power of 2, it can also be called 5 square. And if you have 5 raised to the power of 3, it can also be called. Have you ever wondered why it is referred to as square and cube? Well, that's very easy. This is because the area of a square is being found by multiplying its sides, okay? That's length times length. So if we have 5 here and 5 there, so it's going to be 5 times 5. Then what about that of a cube? Get the volume of a cube by multiplying its 3 sides, the length, the breadth, and the width. So by the time we say 5 times 5 times 5, we get 125. So we can simply say that 5 square gets its name from the shape square, while 5 cubed gets its name from the shape cube. So it's not surprising why 5 raised to the power of 2 is referred to as square, and 5 raised to the power of 3 is referred to as 5 cubed. It shouldn't come as a surprise because they are being obtained from a square, which is a 2-dimensional object, and a cube, which is a 3-dimensional object, which are common objects we see in every day-to-day life. Think of the shape of a cube of sugar. It's a cube, right? So how about this shape and this one? You can all see that these are things we come across in every day-to-day life. So this is it on Introduction to Indices. In the next video, we'll be looking at the laws of indices and how to interpret them. I'd love to see in the next video. Thanks for watching.